Hello everyone, I'm Singbe Park, a philosopher of science at UNIST, Ulsan National Institute of Science and Technology. In this video, I briefly summarize Chapter 9 of my book, Embracing Scientific Realism. The target viewers of this video are the philosophers of science and mathematics who have already published and aim to publish more on scientific realism and mathematical realism. Mathematical realism holds that mathematical entities such as triangles, functions, and numbers are real. By contrast, mathematical anti-realism holds that mathematical entities are not real. In this chapter, I criticize mathematical realism and defend mathematical anti-realism. Let me first distinguish between concrete and abstract objects. Concrete objects are spatial, temporal, causal, and mutable. They exist in the concrete world. By contrast, abstract objects are non-spatial, non-temporal, non-causal, and immutable. They exist in the abstract world. Let me now distinguish between concrete and abstract statements. It is a concrete statement, for example, a cat is on the mat. This statement is true in virtue of the way the concrete world is. According to mathematical realism, it is an abstract statement, for example, 1 plus 1 equals 2. This statement is true in virtue of the way the abstract world is. Why should we believe that the mathematical objects exist in the abstract world? Some mathematical realists construct what I call the argument from language. It goes like this. Meaningless sentences result from the attribution of spatial and temporal predicates to mathematical objects. For example, it makes no sense to ask where the cosine function was yesterday. Therefore, mathematical objects are non-spatial and non-temporal. The argument from language is fallacious. Suppose you are pointing to the moon with your finger. An astronomer infers that since there is blood in your finger, there must also be blood in the moon. Just as the astronomer's inference is fallacious, the argument from language is fallacious. The fact that it is meaningless to ask where the cosine function was yesterday is not a fact about the cosine function, but a fact about the mathematical sentence. Just as the astronomer should investigate the moon, not the finger, mathematical realists should investigate mathematical objects, not mathematical sentences. The abstract world is queer. According to Euclidean, Lobachevskian, and Riemannian geometries, the sum of the three angles of a triangle is 180 degree, smaller than 180 degree, and larger than 180 degree respectively. According to mathematical realism, these three mathematical statements are true because they correspond to three mathematical facts in the abstract world. In my view, however, the three mathematical facts cannot coexist in the abstract world. Imagine that there is an object called a tricle. It changes its shape from a triangle to a circle, and from a circle back to a triangle every second. A tricle is non-causal and non-spatial, for both a circle and a triangle are non-causal and non-spatial. However, it is temporal and mutable, for it changes its shape as time passes. Is a tricle a mathematical object? Does it exist in the abstract world? Mathematical realists owe us answers to these questions. Mathematical realists traditionally attributed 5 properties to mathematical objects, namely being non-spatial, non-temporal, non-causal, immutable, and necessary. However, indispensabilists claim that mathematical objects, although abstract, are not necessary. Causal Platonists claim that mathematical objects, although abstract, are causally efficacious on human brains. The fact that mathematical realists have jettisoned the two properties raises an interesting issue. What are the defining characteristics of mathematical objects? Which of the 5 properties are essential, and which of them are accidental? Mathematical realists owe us answers to these questions. How do you know that mathematical objects exist in the abstract world? According to rationalists, we have the cognitive faculty of reason, and it enables us to grasp mathematical objects in the abstract world. In my view, however, rationalists multiply cognitive faculties and entities beyond necessity. They are no different from unicorn theorists who claim that unicorns exist. We have the U faculty, and it enables us to see unicorns. Causal platonism holds that mathematical objects, although abstract, causally affect human brains. An immediate objection to causal platonism is that we cannot gather empirical evidence for it. Causal Platonists reply that causal Platonism is a priori, and it is derived from the investigation of mathematical knowledge. My response to this reply is to say that causal Platonists should investigate mathematical objects and human brains, not mathematical knowledge. To investigate mathematical knowledge is just as mistaken as to investigate the finger rather than the moon. Let me now turn to the famous argument for mathematical realism called the Quine-Putnam indispensability argument. It can be summarized as follows. Mathematical statements are indispensable ingredients of our best scientific theories. All constituents of our best scientific theories, including mathematical statements, are confirmed by observational evidence. Therefore, we can justifiably believe that mathematical entities exist. Let me raise some objections to the Quine-Putnam indispensability argument. Empirical science is an attempt to describe the concrete world. Indispensabilists claim, however, a mathematical statement is not a description of the concrete world, but a description of the abstract world. Therefore, they owe us an account of how an abstract statement can be useful in empirical science. Indispensabilists might reply that a mathematical statement is useful in empirical science because it is an indispensable component of a scientific theory. Logical positivists, however, would counter-reply that a mathematical statement is analytic, but it is useful in empirical science because it is an indispensable component of a scientific theory. Indispensabilists are committed to the distinction between concrete and abstract statements. But there are tricky statements. For example, the concrete statement is inhabited by mathematical entities. Numbers and cats exist in the concrete world. Are these statements abstract or concrete? Why? Indispensabilists owe us answers to these questions. Indispensabilists claim that it is intellectually dishonest to believe that theoretical entities are real, but not to believe that mathematical entities are real. In other words, scientific realists ought to embrace mathematical realism. In my view, however, this claim is disputable. The interaction between DNA and ultraviolet rays explains new phenomena. For example, the interaction between them explains why skin cancer occurs. However, mathematical objects cannot interact with one another and with concrete objects. Therefore, the existence of mathematical objects cannot be as highly confirmed as the existence of DNA and ultraviolet rays. The indispensability argument implies that mathematical statements are subject to empirical refutation. An objection arises. Why is it that the mathematical statement 1 plus 1 equals 2 was not refuted in the history of science? Indispensabilists answer that we can negate a mathematical statement, but we don't, because if we do, we have to negate a lot of concrete statements. I call this thesis mathematical convenientism. According to mathematical convenientism, we choose a belief system over another, not because we have more evidence for the former than the latter, but because it is more convenient to do so. Mathematical convenientism commits the consequential fallacy, and it destroys all beliefs in a belief system, including mathematical realism. Let me propose an alternative to mathematical realism and fictionalism that I call mathematical inferentialism. It consists of the psychological, semantic, metaphysical, and epistemological theses. The psychological thesis is that a mathematical statement facilitates deductive inferences between synthetic statements. The semantic thesis is that a mathematical statement is true when it is synthetically adequate. To say so means that a true mathematical statement entails only some true synthetic statements when it is supplied with other true synthetic statements. The metaphysical thesis is that there is no such thing as the abstract world. It is not the abstract world, but the concrete world that renders a mathematical statement true. The epistemological thesis is that we can know that a mathematical statement is true by confirming its synthetic consequences. Mathematical inferentialism is more virtuous than mathematical realism and fictionalism. I just summarized Chapter 9 of my book, Embracing Scientific Realism. Thank you for watching. See you next time. Bye.